Hey, you guys, this is Mrs. All Day from Childs High School. Welcome to Algebra 2 General. We're working on online remote learning. This is Tuesday, April the 7th, and we are going to finish up 7.1. We did 7.1 yesterday, growth and decay, and today we're going to do interest and population. All right, so go ahead and get out your notes that you're going to be taking notes on. There were 4 pages of notes. The first 2 we did yesterday. Okay, so this page is from yesterday, and this page is from yesterday. So you're going to go to the 3rd page, and this is today's. So let's go ahead and write on this one. Let's put 7.1b, or part 2, however you want to put it. And let's put today's date, April the 7th. All right, so let's get started. If you borrow money, you have to repay the amount you borrowed plus interest. Okay, that means they're going to charge you something for you putting your money in their bank. All right, interest is the money paid for use of the loan. But there's another type of interest, okay? You can earn interest if you have a savings account. So if you put your money in their bank, then you can accumulate interest. All right, if you put $200 into a college savings account for 4 years, and the account pays you 4% interest annually means yearly, is this an example of exponential growth or decay? So think about it. You're putting money in a bank, okay, and you're letting it sit there, and it's accumulating interest. So that's going to be growth because your money's going to grow. So this is exponential growth. Now the next question says, what is the y-intercept? The y-intercept is the original amount that you started with. So what did you start with? All right, $2,000. All right, so that's just an example just to kind of get you in the mind frame of thinking about interest. All right, now we're going to talk a little bit about rate. All right, the rate of interest. The rate of increase is the growth rate, and it's used, we use the variable r. So r is going to stand for rate. Because this is exponential growth, because it says increase and it says growth, the base of the function b has to be greater than 1. Remember, yesterday, whenever we were doing exponential growth, we said y equals a times b to the x, and that b had to be greater than 1. So to find b, the growth factor, you're going to look right here. B equals 1 plus r. So if you're adding the rate to 1, then b is going to be greater than 1. Makes sense? All right. Now, in a situation with exponential decay, which is b, the decay factor, r is the rate of increase. It's also called the rate of decay. The rate of decay is usually expressed as a negative number. So you're still going to use b equals 1 plus r, but your rate is usually going to be like a minus 5%. Okay, it's going to be a negative number. All right, so now I want us to start memorizing this formula. And here, this is the formula that we're going to use. Let's go ahead and write it off to the side while I talk about it. A of t equals lowercase a times 1 plus r, close the parentheses, to the t power. If you write it out, it's going to be embedded in your memory better than if you don't write it out. All right, so let's talk about what each of the letters mean. All right, the A is going to be the amount that you get after a time period, okay? And the amount that you get after a certain time period. All right, the lowercase a is the initial amount. Like if you were doing the $2,000 earlier, that would be 2,000. The R is the rate of growth or decay. So if we were going to do the one that we just looked at, $2,000, so the rate of growth or decay for the one we just did was 4% interest annually, and it was growing. So the R represents the rate. So in the previous case, that would be 0.04. The A would have been 2,000. the A of t, the time period was 4 years. And then we have 1 plus, and the t, the exponent t, is the number of time periods, and that's always going to be in years. So put over here, t equals number of years. It's not going to be months. It's not going to be days. It's not going to be weeks. It's going to be years. So that's what t is the number of time periods. All right, let's try this formula. So let's go ahead and write it again. A of t equals lowercase a times 1 plus r to the t power. All right, as we read it, we're going to kind of dissect it. All right, you put $2,000 in a college savings account. That's my original amount. That's A. A is $2,000. And it pays 4% interest annually. Okay, 4%, that's going to be my rate. So my R, I'm going to write 4% as 0.04. How much money will be in the account after 4 years? All right, so T, my time, is going to be 4. We're going to focus on the 4 years first. Just ignore the 6 for a minute. All right, let's go ahead and plug in what we know. We already know that this is growth, right? This is a growth problem. All right, so A of T is 4 equals lowercase a, 2,000 times 1 plus the rate, which is 0.04, and the time, which is the exponent, is 4. All right, the first thing you're going to do is you're going to add the 1 plus the 0.04. So when we add that together, we get 1.04 to the 4th. All right, now I want you to go to your calculator and we're going to plug that in. I'm going to show you how to do that. So I'm going to go to my calculator. I'm going to take 1.04 and I have that plugged into my calculator. Now I'm going to hover over the button I'm fixing to press. I'm fixing to press this X to the Y. The number we just plugged in is being substituted for the X. When I hit this button, there's a little caret that shows up. It's like a little arrow. That's where you hit the 4 button. That means you are putting the 4 as the exponent y. And then you press the equals button. So we're going to round that to 1.17, but leave that number in your calculator, please. All right, so we're going to go back here. A of 4 equals 2,000. When we input 1.04 to the 4th in our calculator, we got 1.17. Now we're going to multiply that 1.17 by the 2,000. So go back to your calculator. You left that number in there. Don't worry about rounding it. Leave it in. That's more specific. We're going to multiply that by 2,000. 2,000 equals $2,339. Now this is money, so you round to 2 decimal places, and 72 cents. All right. So let's go ahead and write that as our answer. A of 4 equals $2,339.72. So how much money will be in the account after 4 years? That's our answer. All right. Now, let's do the next part. How much after 6 years? Well, we actually already have the problem set up. We've just got to replace, instead of 4, we're going to replace it with 6. So A of 6 equals $2,000 times 1 plus 0.04 to the 6th power. All right, A of 6 equals $2,000. 1 plus 0.04 is 1.04 to the 6th. A of 6 equals $2,000 times, now we're going to go plug that into our calculator. So I'm going to close out on my calculator because I don't trust my calculator. Sometimes it leaves a number in there and does something to it. All right, so we are going to plug in 1.04 to the 6th power. All right, so you do that, 1.04. I'm hovering over the button that you're going to use. Tap that one. Now you're going to do it to the 6th power this time. and you have to press the equal sign. 1.27. We're going to round that, but do not round it in your calculator. So 1.27. All right. A of 6 equals, go back to your calculator, and you're going to times that by 2,000. So times 2,000 equals $2,530.64. All right, so let's write that here. $2,530.64. So that's how much money will be in the account after 6 years. Okay, pretty interesting, right? All right, let's go to the next problem. You invest $1,000 in a savings account. All right, that $1,000 is going to be your A. So A equals 1,000. It pays 5% annual interest. All right, that's your R. Your R is 0.05. If you make no additional deposits or withdrawals, how many years will it take for the account to grow to at least 1,500? Now, they're asking me how many years. So for T, that's what they're asking me. And they say, okay, how long will it take for your account to grow to at least 1,500? Your 1,500 is actually going to be what your A is going to end up being, your 1,500. So they want to know how long is it going to take to get there. All right, let's see what we know. Let's plug it into our formula. A of T equals lowercase a times 1 plus R to the T. All right, our A of T is 1,500 equals, our A is 1,000. 1 plus our rate is 5% to the T. All right, we're going to see if we can get T isolated as much as possible. You're going to find out that we won't be able to do it too much. So these two are being multiplied. So the inverse operation of multiply is divide. So divide both sides by 1,000. These two cancel. The double zeros cancel. So 15 divided by 10 is 1.5 equals, and we're going to go ahead and add the 1 plus the 0.05 and get 1.05 to the T. All right, so our first step was to try to isolate T. Okay, we tried to isolate as much as we could. All right, our next step, our second step, is to make a table. Make a table. Now you could always do a graph when you make a table, but that's just a lot of extra work, right? All right, so T is going to be my number of years, and I'm going to see what it would equal. Now, don't erase all this, but I'm going to go back to one of the original problems that we had just written down, because it's going to be the easiest one. I'm going to do it in purple. So the 1,500 equals 1,000 times, oops, sorry about that, times 1.05 to the T. Now, let's just pick a number randomly. T. Let's say T was 3 years, okay? So I'm going to do this. I'm going to see if when I multiply 100 times 1.05 to the third power, I'm going to see what number that gets me. All right, so I'm going to go to my calculator, and I'm going to type in 1.05 to the third power, and then I'm going to times it by 1,000, and I'm going to come and I'm going to write it in my table where you see my smiley face. All right, so we're going to go here, open up my calculator. I'm going to type in 1.05, hit that button. I said to the third power, that equals, and I'm going to times that by 1,000. And let's see what I get. 1,150, let's call it 58, $1,158. All right, $1,158. Well, that's getting pretty close to 1,500, but not quite. All right, so let's do another year. Let's skip up to 5. Let's do 5. So let's do in our calculator 1.05 to the 5th, and then let's times it by 1,000 and see if we get 1,500. All right, so I'm going to pull my calculator up. 1.05 to the 5th is 1.27. I'm going to times that by 1,000. 1,276. Okay, 1,276. We're getting there. What do you think? Let's jump up to 8. Let's see what happens if I turn that 5 into an 8 this time. Okay, so let's go to our calculator. I'm going to type in 1.05, hit the button to the 8, hit the equal sign. That's 1.47 times 1,000. 1,477. That's getting closer. But they want to know how many years will it take you to get at least 1,500. Not close to it, but at least that amount. All right, so I don't know. That's really, really close. Let's go ahead and try 9 and see what happens with 9. All right, go to your calculator. We're going to plug in to our calculator 1.05, hit that button to the 9th power, hit the equals button. That's 1.55 times 1,000. Aha, 1,551. 1,551. You guys, that's it. That's as close as I'm going to get, I believe, to 1,500. So that's the number of years. So it says how many years. We're going to put about 9 years. And that's our answer, because they said how many years will it take. Well, that was a little different, huh? All right, let's look at this third example, still on the front side. Suppose you put $100 into a savings account. All right, that's A. That's your original amount. And it earns 4% annual interest. Okay, well, that's R, 0.04. How much money would you have at the end of 1 year? All right, 1 year, that's time. All right, so we have our A of 1 equals our $100 times 1 plus 0.04 to the 1. Well, this one's going to be one of our easiest ones. So A of 1 equals 100 times 1.04 to the 1. Well, we know that that's really just still 1.04. And this one we can actually do without a calculator. Because if you're multiplying 1.04 times 100, you move the decimal 2 places to the right because 100 has 2 zeros in it. And so you're going to have $104. So how much money would you have at the end of the year? $104. That's how much money you would have. Not really that much, right? $4 more than you had. All right, let's go to the next page. Write an exponential function to model each situation. Find each amount after the specified time. All right, so these are the population problems that I was telling you that we were going to do. Using the same formula though, you guys, okay? So we're still looking at A of t equals A times 1 plus r to the t. All right, a population of 200,000 grows. Okay, that's the original amount. So that's what lowercase a is going to be, is 200,000. It grows 2.6% per year. All right, that's going to be my rate. Now, in red, 2.6%. To change that to a decimal, you drop the percent sign and move that decimal 2 places to the left. So that's going to be 0.026. All right, 2.6 per year for 12 years. So t, my time, is going to be 12. All right, so let's plug that in. A of 12 equals 200,000 people. 1 plus 0.026 to the 12. Okay, this first part says, what's the equation going to be? All right, that's the equation. Now, to get the amount, I'm going to work from that equation on down to figure out, how much that will be. All right, so we're going to say A of 12 equals 200,000, and then 1 plus 0.026. All right, so let's look at this for a minute. We're going to plug this part into our calculator. So 1.026 to the 12th. All right, so I'm going to go get the calculator again. And we're going to plug in 1.026. All right, we're going to hit that X to the Y button. And we're going to do it 12 years. So to the 12th power equals, now leave this number in there. That looks like 1.36 to me. Okay, so A of 12 equals 200,000 times 1.36. Okay, now we're going to multiply that times the 200,000. All right, so go to your calculator because you left the number in there. You're going to multiply it by 2, 1, 2, 3, 4, 5. Press the equals button. All right, write this down. 272,143.7. All right. Let me write it now. 272, 143.7. All right. Tell me something. Was this a growth or a decay? Right. It's a growth. The number increased, right? Now it says that it grew. Now you can't have 0.7 of a person. Some people would say, well, yeah, you can. Maybe somebody's pregnant and they haven't been born yet. Anyway. Right? All right, let's go on to the next population problem. All right, we have our standard equation up there at the top to look at. All right, a population of 1,540,000. Okay, that's going to be our A. Decreases. Aha. I'm going to put up here that this was an increase, so we remember that. So now that we're fixing to do our rate, and I'll move my decimal 2 places to the left, that's going to be 0.019. This is a decrease. That's very important. Let me highlight this somehow in pink so we remember that this is a decrease because we don't want to forget that in a minute. All right, and then it's 1.9% per year for 8 years. So my T is going to be 8 years. Okay, they want the equation first. So A of 8 equals 1,540,000 times 1 minus 0.019 to the 8th power. All right, you could probably do that in your head, but just to make sure, we're going to go to our calculator and we're going to do 1 minus 0.019 to see what that's going to be. We're used to adding it. We can definitely do it in our head. So that's 0.981. You really read it as 981 thousandths. All right. So I'm going to substitute that right here. 0.981. Let me go back. A of 8 equals 1,540,000 times 0.981 to the 8. All right, that's what we're going to have to go put into our calculator. So I already have it in there. So I'm just going to hit the XY button, and I have to do it to the 8th power. So I'm going to press the equals button, and that looks like it's approximately 0.86. All right, so A of 8 equals 1,540,000 times 0.86. All right, now I still have that in my calculator, so I'm going to multiply that times that big population number. So times 1,540,000 equals. All right, are you ready? 1,320,908.6. All right, so I'm going to write it now. Oops. A of 8 equals 1,320,908.6. Fix that little comma right there. All right, guys, let's go down to this problem about a ball being dropped from a height of 10 feet. All right, so the original height, think of it as maybe you're standing on a trampoline, okay? And you have a ball in your hand, and you're reaching your arm out, and you drop it from a height of 10 feet. So the original height is 10 feet. All right, that's going to be our lowercase a. The first bounce was measured as 60 inches, and then the second bounce was 30 inches. So you see it's being cut in half by 2 each time, but they're using inches. So we're going to take the 10 feet, and we know that there are 12 inches in a foot. And so we're going to say that it started out at 120 inches. That's where you drop the ball from. Okay. When you drop the ball from 120 inches, the first bounce was measured as 60 inches. So you're going to subtract 60 inches from it to get 60. And so that shows you that it was half the height. All right, so we're going to write an exponential function to model the height of the ball. So A of t equals 120 times 1 minus a half, which is 0.5 to the t. So A of t equals 120 times 0.5 to the t. All right, so that's our model equation. All right, what we're going to do next, it says how high was the ball on its sixth bounce? All right, so A of 6, that's 6 bounces. Now we've been thinking of t as time. Now we're kind of counting how many bounces has elapsed in a time period. So after 6 bounces equals 120 times 0.5 to the 6th. All right, we're going to go to our calculator and we're going to punch in the 0.5 to the 6 and see what that is, okay? All right, 0.5, hit the X to the Y button to the 6 equals. Okay, leave that in there. That is, I'm just going to write down 0.016 and round it. But leave that in your calculator. All right, so A of 6 equals 120 times 0.016. All right, now we're going to multiply that times the 120. It's already in our calculator. So times 120, press the equals button, 1.875. Okay, so A of 6 equals 1.875. Now what was this? How high was the ball on its sixth bounce? Well, we did inches. So that's how high it was. It wasn't quite 2 inches. It's a little bit more than 1 inch. All right, this was a decay because we had to subtract. The one before was a decay because we had to subtract. The one before that was a growth because we added. All right, let's look at this next one. Suppose a 2018 Ford F-150 4x4 truck costs $27,700. All right, that's the original amount. It's going to be A. and depreciates. Now, depreciate means the price goes down, right? So that's already a decay. Let's go ahead and write decay here. By 12% per year. We know that's going to be the rate. Write an exponential function to model the value of the truck after t years. All right, so A of t equals the original amount, 27,700, times 1 minus, because it's decaying, it's depreciating, 12%, which is 0.12, to the t. All right, we got to simplify our original problem. We're going to say A of t equals 27,700 times. Now, we have to do 1 minus 0.12. Well, that's 0.88 to the t. You can do it in your calculator if you want. That's our original problem. All right, now they want to know how much would the truck be worth after 5 years. All right. That 5 years is going to be our t. A of 5 equals 27,700 times 0.88 to the fifth. All right, that's what we're going to have to go to our calculator right now and go plug in. Make this a little bit better readable. 0.88 to the fifth. All right, so we're going to do 0.88, hit the X to the Y button, to the fifth, hit the equals button. 0.528. Let's write that down. Leave that in your calculator, though. A of 5 equals 27,700 times 0.528. All right, now you're going to multiply that 0.528 that you have in your calculator times 27,700. So we're going to keep that big long decimal in there, times 27,700. Press the equals button. $14,618.17. All right, after 5 years, the truck's going to be worth $14,618.17. All right. All right, so that's the end of 7-1. So let me look at your homework. I'm going to pull that up real quick, where it says interest and population. Textbook, page 439 to 441. Problems 8 through 9, 26 through 30, 43, and 45 and 46. And then make sure you do your mandatory upload because we finished section 7-1. Remember, after each section that we finish, you do the mandatory upload, which is the standardized test prep worksheet that you upload to Focus. All right, so I guess I'll see you guys tomorrow. You can see that tomorrow we're going to move on to 7-2. So we'll do part 1 of 7-2 tomorrow, which is Wednesday. And then part 2 of 7-2 on Thursday. And that ends your week for your online remote learning for this week because Friday is a holiday. So catch up on any homework assignments and downloads that you need to do. As of Friday, you should have 6-6, 6-7, 6-8, 7-1, and 7-2 downloads. So you should have 5 grades in the grade book. All right. Thank you, guys. I will see you tomorrow.